All right, so given this diagram for a relative motion problem where we have a train traveling 3 meters per second down and a passenger traveling 1 meter per second to the right, what is the velocity of the passenger P with respect to the observer A? Would you know how to solve? If not, continue watching this video. We can start by looking at from last time. We have this equation here for the velocity, where Vp/A is the velocity at point P with respect to A, which in our diagram, it's the velocity of the passenger with respect to the observer. Then velocity P/B is the velocity of P with respect to B. So this would be the velocity of the passenger with respect to the train, and then velocity B/A is velocity of B with respect to A. This would be the velocity of the train with respect to the observer. But this equation models relative motion 1D. We could transform this into 2D or 3D by replacing the 1D velocity with the 2D/3D velocity vector, and we get this expression here. This is the expression for the velocity in 2D/3D for relative motion. And we can apply this to our equation by labeling A the observer, B the train, and then P the passenger. If we write down our 2D/3D equation here, we can label Vp/B equal to 1 meters per second to the right, because that's the velocity of the passenger with respect to the train. We can label Vb/A 3 meters per second, because this is going to be the velocity of the train with respect to the observer. So we can plug both these in and get this expression here, noting that these values are not in the same direction, so we can't just add them. We have to use the Pythagorean theorem. Draw our train vector 3 meters per second down, then our passenger vector 1 meters per second to the right, and then we can draw a resultant vector Vp/A. This is going to be the vector that the observer is going to see the passenger walking at. It makes an angle of theta, so that's going to be the angle that the observer sees the passenger walking at. We can find Vp/A using Pythagorean theorem. Do that, we can plug the values in and we get this expression here. Then we do some simple multiplications and we get this approximately for the final answer. And this is going to be the velocity the observer sees the passenger moving at. And we can also solve for the angle theta between them. We can do this by using simple trig. Tan theta equals opposite over adjacent, and that's just going to be equal to 1 meters per second over 3 meters per second. Take the inverse and we get 18 degrees for the final answer. This is going to be the angle relative to the train that the observer sees the passenger moving towards. We can look at this visually. If we draw the passenger and we draw the velocity B going down, the vector that the observer is going to see the passenger walking at is going to be this vector here, and that angle right there is going to be 18 degrees between them. This is going to be the direction and speed that the observer is going to see the passenger moving at. This makes sense because since the train is moving down, the observer sees the guy in the train that's moving right relative to the train slightly being swayed down because the train is moving down.